So I'll introduce the next speaker is Antoine the Comite. He's a final year PhD student at UC Louvain in Belgium, working with Philippe Lefebvre. He will talk about the influence of target reward on motor planning um, in online motor decision. And Barbara, the rest of us can just mute and
Okay, so can you see the slides?
yes.
Yeah, okay. Thank you. So as Nidhi said, I will be discussing about reaching movement and more specifically about how those rewards will interact with reaching movement while we're performing this movement. So let's start with an example. So you are in front of this basket of apple and you are hungry. So you decide to eat one of these. So to do that, the command view in reaching movement is that there are two parts of the process. The first one is to select which one of these apples you are going to reach. So this selection will be dependent on many parameters, and once the target is selected, you initiate the movement and start reaching for the apple you chose. So if we looked at both parts of this process, so the first one was target selection. So the target selection will be dependent on many parameters. For example, the position of the apple will have an influence. So you will be more likely to grasp an apple which is close by than another one which is far away. The expected gain as well. So if you are hungry, you want to eat a lot of food, so you will be more likely to go towards a huge apple than the smallest one. And the biomechanical cost could also have an influence. So if you, for example, if you have to grasp an apple which is at the bottom of the basket, it will cost you more energy because you will have to move the other ones around. So this is the first part of the movement. So you have to select when you have different options, which one you want to do. And once this is done, you can start initiating the movement. And then this movement execution will also have influences throughout different parameters. So for example, the target shape. So this means that if instead of reaching for an apple, you are reaching for a grain of grape, you won't do the same movement because the target is smaller and it's more fragile. Obstacles will also have an influence. So when you execute the movement and suddenly you have a wasp that's hanging around the basket, you will have to avoid the wasp. And so it will change the way you execute the movement. And the last one is the impact of the reward. So if you are very hungry, you will have more interest in grasping one of these apples. So the movement, so it is shown from saccadic eye movements and reaching movements that when you reach for something which is more rewarding, you will have a more vigorous movement. So your movement will be faster with smaller execution time. And what we want to do in this study is we want to see whether this reward over here, so when you execute the movement, if there is a perturbation which is huge enough, for example, someone bumping into your arm or a wasp that lands on the apple you selected, you might have to change the target you selected and you have to change the apple. And you want to see how does the rewards, so how much each of the different apple will have so how much this reward will have an influence on the way you select a new option. So to quickly come back to this example, let's say you have selected that very apple, you start the movement, and then you have the wasp showing up. And what you want to know is how much of the reward of this apple, for example, will influence the way you select it or not. So this is the question we are asking, and the way we are addressing it is using this paradigm. So we had participants sitting on this skin arm robot, so they could perform 2D movements by moving the handle over here. So we occluded the vision of their arm so that they only see this point, which represents the position of their hand. And we ask them to perform movement from these home targets to any of these three targets. So each of these one was associated with a reward. So this was points, and at the end of the experiment, they were paid depending on how much points they collected during the experiment. And we considered two reward distributions amongst the targets. So the first one in which all the targets had exactly the same reward. So there were no differences in between the targets. And in the second condition, the central target was more rewarding than the other two. So during movement, we also, in order to introduce the replanning and reselection of targets, we introduced some perturbation loads. So as the hand crossed this line, they could experience leftward or rightward perturbation with various intensities. And during the movements, we collected kinematics, so the position, velocity, and forces at the hand, as well as EMG activity of pectoralis major and posterior deltoid, which are the shoulder flexor and extensors. So if we look at first the kinematics, so here are the results that we obtained for a typical subject. So in the same condition, when all the targets had the same reward, we observe that when there is no perturbation, most of the time you go to the nearest target. And if you introduce a perturbation to the left, for example, you see that the larger the perturbation, the more trials will reach this target. And this is the same for the right perturbation. And if we now introduce the variation in reward, in which we decrease the reward of the lateral target with no perturbation, we observe similar behavior as we had before. But as we introduce the perturbation, we see that there is, at least for this subject, there seems to be way less trials that switch to this lateral target. And if we want to look at the behavior of all the subjects and of the average subject, it is what we obtained. So we reported the switch proportion, so which is how often one of the two lateral targets was reached with respect to the perturbation load. So you observe that this is the first line of the preceding graph. As we increase the force, on average, you are more likely to go to the lateral target, and the same for the other direction. But when we introduce reward, we observe for all the subjects and even on average that the switch proportion will decrease. So if the lateral target is less rewarding, you will be less likely to switch during movement. So this first experiment kind of answered our question. Indeed, the reward will be taken into account while we perform this online motor decision. So why we have to select between several options, we will take into account this reward of the reward of the different options. And another question we wanted to answer is when we look at this condition, when all the target at the same reward, for many of the subjects at every force level, we had trials that go to the lateral targets, but trials that also go to the center target. And we wanted to see whether before the perturbation, it could be possible to know what the subject is going to do. So to do that, we look at what's happening before the perturbation onset, and we gather together all the trials that go to one of the two lateral targets and all the trials that goes to the central target. So here are the traces for forward velocity and posterior deltoid activity for the lateral target. And what is surprising is that if we look at the same data, but for the trials that reach one of the central targets, so the central target, we observe an increase in these two parameters. And specifically, we observe an increase in the activity of the posterior deltoid. So this could suggest that for the subjects, we have, if the subject has a higher EMG activity in this muscle, at perturbation onset, it is way more likely to answer the perturbation and go back to the central target. And in order to see, to go deeply in this effect, we designed a second experiment where the goal was to artificially increase the activity of these muscles. So to do that, we had a very similar experiment, except that in half of the trials, we had this background load. So the load was started when participants entered this home target and stopped when they reached one of these targets. And it was always pushing to the left. And then we also had perturbation when they crossed the line, so similarly to what we had before, but in this case, all the targets had the same reward rule. So we didn't play with reward anymore. We just wanted to see the effect we observed in the last experiment. So if we look at the no background condition, which is the same condition as the condition called same in the first experiment, we observe that the larger the force in one direction, the more trials will go in, will end up in this direction. And if we look at the same trials with the background load, there looks like there are some differences in the two conditions. So these are the same subjects, and if we want to have a better look at that, so here we compare the two values here. So we'll compare the mean values at population level as well as SEM, and what we observe is that for the left target, there is a significant decrease of the switch proportion to this left target when we add the background load. So this is coherent with what we observed in the first experiment. That is, when you perturb the hand, so if you pre-excite the muscle pushing in the direction of one target, you will decrease the amount of trials that end up in this direction, which is very counterintuitive. And what is even more surprising is that we didn't observe any effect for the right target. So for the same background level, we didn't observe any significant effect on this target. So to pack this all, what we showed here is that first, when you have to select amongst different options during a movement, you will be taken into account the rewards of the different options. The reward will indeed influence online motor decisions. And then we also observe that there is a correlation between the switch probability, so kind of the strategy you will be using, and the background EMG activity. So what does that mean? It means that when you have to perform witching movements and something triggers an online replanning of this movement, you can have two kind of strategies. The first one will be a robust control strategy. So robust means that it's better at responding to perturbation, and then you will be more likely to end up in the center targets. And this strategy is characterized by higher reflex responses to perturbation. And the second strategy will be a more flexible one. So this strategy will will correspond to the one with a smaller EMG activity, and it will be more prone to switch target during movement. So when you have a perturbation, you will be more likely to go to another target during this movement. So with that, I would like to thank my advisors and funders, as well as all the other members of the lab, and would be glad to answer any question. Thank you.
Great talk, Antoine. Thank you for that. We don't have any questions just yet, but let's give the attendees a minute to maybe post their questions. In the meantime, Barbara, if you're still there, do you want to answer a couple of questions that you had that we had to okay, there's a question for you now, I think. There you go. So the question says, did you check the triceps EMG activity, Antoine?
So in previous experiments, so if we go back to this slide here, so we checked in previous experiments the activity of the triceps. The problem is that participants were free to put the elbow as they want. So if we record triceps activity, we don't have stereotyped responses as we have for the pectoralis major. So we would expect behavior. So in the triceps, you would expect behavior similar to what we observe in the deltoid, but the problem is that with the position of the arm, it's not possible to. So depending on how you will put your elbow during the movement, you will have different responses. So we didn't look at it in this setup, at least.
Okay, cool. The next question for you is, how do you expect patients suffering from depression to respond to this task? Would the effect be more marked on the reward or on the perturbation?
So yeah, this is a good question. And one thing that we observe is that amongst participants we recruited, we had many different behaviors. So some of them were more on the robust strategy, some others were more on the flexible strategy, and yeah, we had many differences across subjects, and even in the subjects, depending on the block. For example, at the beginning of the experiment or at the end of the experiment, we had slightly shifting behaviors towards, like, if they are bored, they will be less likely to answer, just want to finish the experiment. So I would say it really depends on the person, but it could be in this case more relying on the flexible strategy and then just let it go when there is a perturbation.
I see. Okay, and one more question. So, what was the reward protocol distribution? What was the reward protocol or distribution that was implemented? How was the reward implemented?
Yeah, so each target, so the large reward gave you 5 points and the smaller reward give you 1 point. And at the end of the experiments, so there were a scale and participants knew beforehand, so they could earn from 10 to 15 euros, and depending on how much they scored during the movements, they get and yeah, the compensation accordingly.
Okay, cool. Thank you. Since we actually